Today on this lecture we will discuss about the simplification of context free grammar. So, why we remove simplify the context free grammar, what are the purpose of this and what is the context free grammar already we know. So, we have suppose I have a context free language, for that we have many context free grammar. So, maybe some redundant will be there which is the optimized grammar, we have to, that is why we need for the simplification of the context free grammar. For any context free language we have more than one context free grammar. So, here already we know the what are the context free grammar, we know the tuples this in context free grammar then here all tuples already we know. So, in this L is a context free language and G1 G2 are context free grammar where both G1 G2 are equivalent. So, here we have taken a context free language. For this we have G1 and G2 grammar context free grammar and both are equivalent. Simplify CFG, we remove all the redundant from the grammars, all the redundant from the grammars. So, removal of the, this is the redundant, how this removal of null production, removal of unit production, removal of useless productions. So, these three type of redundant can be removed from a context free grammar. So, here we have already known that Chomsky normal form, we will go to the Chomsky normal form, Grivak normal form, there is a simplify, there is a conversion to from context free grammar to Chomsky normal form, context free grammar to Grivak normal form, after that it will come. From these two, when you will go for the Chomsky normal form of a context free grammar, you must have to remove, you have to remove these all three type of redundant. Then after you can go to the Chomsky normal form. Also like that Grivak normal form, you have to first you have context free grammar, then you have to simplify it, remove all the redundant, then go for the Grivak normal form. Later on we will see that what are the Chomsky normal form and Grivak normal form. So, here we will go to the what is removal of null production. This null production means we have some epsilon production. So, we can remove that epsilon production, but remember one thing, when you will remove the epsilon production, if your language is not deriving empty string, then you can remove that epsilon, and after removing the epsilon production your grammar also generates same number of string whatever previously it was generated. It is not that you remove some production, then whatever string was generated previously and some string are missing from the new grammar. So, you have to take care about this, you have to remove the such way that whatever your language definition will not be changed. So, this is the null production, means we have to remove the epsilon production, means empty productions. So, here how to remove, suppose this grammar, you see here grammar is variable with a epsilon, then we can remove it. If it is from starting symbol deriving epsilon, that cannot be removed, you have to do it in different ways, but here in this case it is, see what is the minimum string generated by this grammar, what is the minimum string, if you will check it, this minimum string will be generated by the grammar, this minimum string will be generated by the grammar here. You can say this is a you can say this is, you take another string here, example, let me take example here, suppose here B B and another is A, suppose this grammar is given and here is the it is given that A, this grammar is given. So, we have to remove the epsilon production. So, from you check there is a production B to epsilon, B to epsilon is there. So, B to epsilon is the epsilon production or null production, we have to remove it. So, what is the first step we have to do? What is the first step? You see here B epsilon. So, now we have S to A B, S to A B. Now, you remove this B epsilon is removed, then wherever is B, just make it epsilon, make it put there epsilon. So, now we remove this B to epsilon. Now, come to A. A having already two production, one is B, B, A, another is A. So, you apply the epsilon from here, epsilon here. If you apply epsilon here, then you will get here B to A, B to A, because already we remove B to epsilon, remove B to epsilon. So, this one when you remove epsilon, then it will be B to A. So, similarly, you can go to the S to A B, then you will find here this is A. So, remove epsilon, in this production this is removed epsilon, removed B to epsilon or put B to epsilon. So, here we got the new grammar, what are the grammar here? Here the grammar is S to A B, and this is A and this is A to B A, and this is A B A. So, now B to B B. So, this grammar, this is the grammar after removing of epsilon production, we got this grammar. You can check a string, suppose here a string is generated S to A, then A B. So, let us check B to another is A to A and B to B. Now, A B is generated by this grammar. So, can it be there? You can check it. So, here you can see S to A and this is A to B, and here is the production A to now A to A and B to B. So, A B is generated there. So, whatever all the strings generated previously, after that also all string is there. You see any string, all string, whatever all the strings generated by this previous grammar including epsilon, then after removing epsilon also same strings are generated by the grammar. So, this is the process to convert remove the null productions. So, here is the another thing, suppose we have one question is given, you have a grammar, this starting is derive epsilon. So, you can see this is a grammar given. So, now this is epsilon and this is A to B B and this is B and B to B. So, this grammar is given, but could we remove it? It could not be removed, because in language itself epsilon is there. So, we could not remove this one, we take a starting symbol from there. So, we can do like this. How to remove? You have to take a S0 to S, then this is epsilon, then S to A, then A to B, then B and A to B is A to whatever grammar is written, same thing you have to write B A, and this is A, and here is the B to this is S0 to A epsilon, which grammar we take one grammar from there which derive epsilon. Okay, these grammar we have to convert this grammar. So, here S0 you have to take a new symbol S0 to S epsilon, then S to B, then A to this is S to A, S to A, the same grammar you have to write, nothing more, same grammar we have to write S to A, then A to B, then B, then B to B. So, this is the grammar of, you have to convert it like that. Then from here, from starting symbol S to, you have to convert this part to CNF or GNF, CNF or GNF, we will go later on this one. So, like that you have to do. If your language itself deriving epsilon empty, so it is we could not remove this epsilon. So, what you do, you have to make it a new state and derive from there. For your starting initial state will be initial symbol will be S0 and S0 will be derive the epsilon. So, this is the removal of null production. Then after we have removal of the unit production. What are the unit production? If a variable to variable, if a production is there, variable to variable, then this is the unit production. Unit production unnecessarily we are taking, suppose we have written here S to A to B, A to B, then B to B. So, why we will take this one S to A, B, or unnecessarily we are taking, we can write, instead of writing we can write here S to B, S to B. So, this is the unit production. So, we are unnecessarily we are taking more symbol. So, this type of production is there, we can remove, and this unit production. So, see in this grammar, here is a grammar given. So, we can see which one is the unit production. So, you can see here S to A, S to A and A to B, A to B, these productions are unit production, these two production are unit production, unit productions. So, these two are unit productions. So, we can remove this unit production. After that your grammar will be remain same, means whatever string will be previously generated, after removing also it will be same string will be generated. How to remove this one? So, first we have to remove A to B. Let us remove A to B. First you have to remove the A to B. Remove A to B. So, what will be there when we will remove A to B? This is A, B, A, then what you have to do? This is A to A, B and B. B will be removed. When it will be B will be removed, just you put whatever symbols of whatever production of B, now you have to write in A. B, A and this is B. So, this is B to B, A and B, B to B, A, just you have to put this B here, B is here. So, this B is here. Now, we remove the unit production of A to B. So, next step we can remove S to A. So, here we have to remove, now this is remove A to B, then after you can have remove S to A, remove S to A, this is remove S to A. So, how to remove this one? Again same thing, we have to make it copy from whatever A production we have to copy to S, remove S to A. So, here you see S to A, B, it will be remain same, we have to remove another production S to A. So, here it will be A, B, B, A and B, and here is the A to A, B, this is B, A and B to B, A, B. Just I substitute here, first in B production, whatever B production we put there in B, in A to B, then after whatever A production we put there S to A. So, we have to just substitute it, this is very easy to do it, remove the, you see there is no unit production in this grammar, there is no unit production in this grammar, you can check it, there is no production, you will find variable to variable, variable to variable. So, in this way we can remove unit production, unit productions. So, this is the process to unit production and this is very easy to remove it, unit production. So, next one is the not useless production. What are the useless production? So, here I categorize two point of view of useless symbol. One is non-terminated, another is not reachable, non-terminated and not reachable. What is non-terminated? You have some grammar, we are deriving some strings, already we know that strings are terminal symbols. So, while we are deriving, sometime it is not terminated, some symbols are, some variable are not terminated, means some variable we could not find the some terminal. So, these are non-terminal. So, here one grammar it is given, you can check it from this grammar, this is a, you will find here B is the non-terminated, B is the non-terminated. Suppose we will take, go to the S, see here we will draw a parse tree, S to B, B, then after B to B, B, B to B, B. So, this B symbol is non-terminated, B symbol is non-terminated, So, you can say wherever B is present any production, all production are useless. So, in which production B is present, production B present, all are useless production, all are useless production. So, we have to remove it. So, here B is a symbol is non-terminated and you can say this B is a useless symbol, B is a useless symbol, B is a useless symbol. See, when you will find this B is a useless symbol, say wherever which production have B, all production are useless production, just remove that productions. So, we will get the result here. What is the result here? So, this grammar will be now S to A and A to A and this is A. This is the grammar after removing useless production. Sometime question will be asking you that how many useless symbols are there in your grammar. It is not asking, sometime it will ask you how many production will be there in useless production is there. Useless production and useless symbol is different. Useless symbol means there is a particular variable and useless production is different. Wherever present this useless symbol, all are useless production. So, these are non-terminated. Another is not reachable. What is the not reachable? Not reachable means obviously we have to start from the starting symbol of derivation. When we will start from the start symbol, sometimes we could not reach some variable, that is the useless, that is the not reachable. You see, we will go to the S, you start from the S to A. So, then A to B. So, like that in B to B. So, if we will start from the S, we could not reach in C variable. Unnecessarily we have written C to AB. So, this production C to AB is not a C not reachable from the starting state. When we derive from the starting state, we never reach to C. That is why C is the useless symbol. C is the useless symbol. So, here we can say wherever C is present, you remove that one. We have to remove that. So, here production is there. So, here you can say this new grammar will be S2 A, then A2 B and this is A, then B2 B. This is the after removing useless symbols. So, these are very simple topic, you can see these are the so one important thing is there, you have to follow this order. If your grammar is there, you have to simplify your grammar, you must have to follow this order. First you have to remove the null production, then after you have to remove the unit production, then after you have to remove the useless production. So, like that you have to follow all these three process. There is a precedence, you can say must have to follow this order, otherwise you will be getting wrong. So, this process you can simplify the grammar, then after we can have conversion of Chomsky normal form and Grivak normal form. Let us take an example, you can take, I am writing a question here, this is many time asked in the GATE question, GATE exam. So, here is a question given S2 B and B. So, A2 A and B and B2 B. So, C2 A and B and C2 B. So, this is the grammar given. So, question is asking how number of useless symbol and useless production, useless productions. Okay, so it is asking how many useless symbols and useless productions. So, option is given, this is you can say, so option A is given, first one is useless symbol is 3, useless production is 5. Then second option is given, similarly I am writing here useless symbol is 2 and useless production is 6. C, useless production is useless symbol, first one is useless symbol is 2 and useless production is useless symbol is 2, useless production is 4. So, D none of this. So, can you identify which option is correct in maximum time in GATE this type of question came. So, here you can say which production is useless production. Suppose you have to take this one and suppose I will derive another is B here, let me modify this grammar, let it this one, you can check it which one is correct. So, here S to A B. So, you can see this B is non terminated, and C is the not reachable. So, these two are B and C are useless symbol. Two B, C are useless symbol. Then wherever B, C present, you have to remove all that one. So, here you have to remove this production and this production and this production. Wherever C present, also remove this one, this one. So, you can see this 6 crosses is there. So, option B is the right option, is the option B. So, all are wrong, because here is the 6 useless production and 2 useless symbol. You can check it, if this type of question, many time this type of question came in GATE exam or competitive exam. So, like that you have to remove, and sometime you have to grammar will be given, after simplify whatever grammar, some grammar will be given, their unit production may be there and some epsilon production may be there, and unit production will be useless production is there. After removing, it will given the 4 option which one is the correct grammar after simplify the contest free grammar. So, like that you have to simplify your contest free grammar. So, this simplification of contest free grammar is very much required to remove the redundant, because already we have some contest free language, then we can have a more than one grammar. That is why this is maybe there is a chance of redundant. So, remove the redundant, we have to follow these 3 procedure, 3 redundant. One is epsilon production, useless, then unit production, and then useless production. So, these 3 procedure must be follow the order. First one is epsilon, then unit, then after useless. Then after whatever you have, you can go for the Chomsky normal form, and whatever you have to go to Gribach normal form. Next lecture we will see that, and these are the references. Thank you so much.